After having decided to renovate a 35-year-old house in Parktown, the owner researched alternative green building methods. As he wanted to add a second story to the house, the architect JVR Architects advised that using light steel framing was the only viable solution. The owner then approached SASFA, the South African Light Steel Frame Building Association, for advice. SASFA agreed to assist with the coordination of the project and drew up a build program that would have the second floor addition of 140 square meters completed in less than 6 weeks. The manufacturer of the light steel frames, TrueMod, used the architect's plans to design the floor beams, wall panels and roof joists. The plans were approved by the appointed engineer Mike Hull. The 0.8mm thick, high-strength galvanized steel sheet specified was supplied by ArcelorMittal. After completion of the changes to the ground floor brick walls, the building of the first floor bedrooms could start. The first step was to install the floor beams or joists. These were all-purpose designed and delivered to the site ready for installation. Due to the low mass of the joists, it was easy for the builder to install without the use of cranes. The floor joists were fixed to the masonry walls below by using high-strength galvanized steel straps. With the floor joists in place, installation of the floorboards could commence. As a first step, a thin rubber strip was fixed to the top of the joists to prevent any creaking when the floor joists deflect under load. We then placed 18mm thick plywood on top of the joists, fixing it down with self-drilling, self-tapping screws. This process is quick and clean and requires only a small team of workers. Using a special quick drive extension on the screw guns, the installer did not even have to bend down to do the installation. The range of fasteners was supplied by Care, Avlock and Simpson Strong Tie. A self-adhesive 3mm thick foam rubber layer, supplied by Global Innovative Building Systems, was then applied on top of the plywood floorboards. This was to prevent the transmission of impact sound from the top floor to the floor below. We then installed 15mm thick high-density fiber cement boards, supplied by Everite, over the full floor area, again using self-drilling, self-tapping screws to fix through the plywood base into the floor joists. This was to provide some mass to the floor to reduce bounce and to serve as an ideal surface to fix the floor tiles. The plumber and electrician had to complete installation of services before we could fix the ceiling underneath the floor joists. After only 2 weeks on site, the floor was completed and the wall frames could be installed. Designed and manufactured off-site to exact dimensions, the panels were delivered ready for erection. Door and window openings were provided in the frames exactly as specified by the architect. A small team of workers lifted the wall panels onto the first floor and installed them according to the layout plan. These panels were anchored down, again using self-drilling screws. Note the cross bracing, which is used to stiffen the wall panels and provide resistance against wind forces. The team then installed the roof joists and purlins. All fixings were done using self-drilling screws with the correct corrosion protection coating. After only 4 weeks on site, the roof sheeting, Chromadeck S-rib supplied by Cloten Steel, could be installed, providing some shade and protection from the weather for all further work below. The external wall panels were then clad as follows. The vapor permeable membrane or house wrap, supplied by Marshall Hines, was fixed to the outside of the wall frames. Intended to ensure weather tightness of the cladding, it prevents unwanted air leakage and also waterproofs the wall. On top of the membrane, 10mm thick polystyrene strips supplied by St. Gobain were fixed to the frames to serve as a thermal break between the external cladding and the light steel frame, thus enhancing the insulation of the walls. On the outside, we used 10mm thick high-density fiber cement panels from Everite, fixed using self-drilling screws driven into the light steel frame. This provided the durable, waterproof external cladding of the building. The joints between the fiber cement boards were sealed using a special sealant prescribed by the manufacturer. While this was happening, the plumber and electrician installed the services that had to pass through the walls. Speedfit Africa did the plumbing using multi-layer polymer pipe and push-fit connections. The carpenter installed the wooden window and door frames in the openings in the wall frames. Glass wool insulation, cavity bat supplied by Isovis St. Gobain, was installed from the inside in the wall cavities to provide thermal and acoustic insulation for the building. The thickness of the insulation complies with the requirements of SANS 517, the building standard for light steel frame buildings in South Africa. Fire-resistant gypsum board, supplied by Gyprock Saint-Gobain and Lafarge Gypsum, was then installed on the inside of all internal wall surfaces, fixed onto the light steel frames using self-drilling screws. Water-resistant board was used in the bathrooms. The joints were rendered and the full surface of the walls and ceilings was skimmed with gypsum plaster to provide a perfect surface for painting. The external paint finish was supplied by Troll on Textures. The second floor was completed in 6.5 weeks, proving that new buildings or additions and alterations can be done quickly and efficiently using LSFB, provided the whole process is properly planned. The owner has found the second story to be warmer than the rest of the house in winter, due to the good insulation of the walls and roof. Acoustics are excellent as sound is absorbed into the walls rather than reflected, as it is the case with heavy masonry walls. A few new lessons were learnt, but the team and the owner felt that the project was a huge success.